Let's take some question based on last step. First, we have find the ratio of stress in both wires A and B. Look, question is providing two wires A and B. Name of one wire is A and name of the second wire is B. It is asking what is the ratio of stress in both wires A and B. Let's solve. First of all, let's draw figure of one wire, figure of a second wire, which is being provided by the question. This is first wire. This is attached. Let's suppose thickness of the wire is more. When it looks more, that's why I'm telling you thickness of the wire is more. It's a R. R is how much? 1 centimeter. And force which was applied on this object is a 10 Newton. This is one wire, wire A. Wire A. Second wire we have, second wire. R is a 2 centimeter, means distance is a 2 centimeter. You can say change in length is a 2 centimeter. And the force, applied force is a 10 Newton. Applied force both are same, but distance is different for both wires. It is asking ratio of stress in both wires. You can take first wire stress A and stress B. Stress of wire 1, stress of wire 2. And just put value of stress, F upon A. F upon A. Since you will have to consider this as a equilibrium. It is in equilibrium. Question is in equilibrium. Situation is at equilibrium. Then we can say restoring force is equal to external force. Here, this is 10. F is how much? 10. Or you can simplify it over here. F upon A multiple A upon F. Remember this A upon F is for second wire. For second wire. So F is a 10 and A is a 1. And for second wire, A is how much? Remember this 1 centimeter is what? This is the radius of the circle of wire. And I was thinking that this is a distance. No, it's not a distance. Okay. So since we have understood that this is the radius of the area cross section of this wire. Area for this wire is how much? 2 upon F is how much? 10. And then simplify it, 2 will come. 2 will come. If you do solve this question, this type of question in that way, then it will provide wrong answer. Wrong answer. Question is providing radius, not area. Not area. So area of the circle is pi r square. Okay. In that equation we will have to substitute value of r. Don't write direct r. So F is a 10, area pi r square. So pi 1, so this will be a square. Multiple area pi and 2 raised to power 2 upon F. F is a 10. This will cut to each other. See over here. See over here. This square was with 1, okay? Pi will cut each other. So finally we have 4. 4 upon 1 you can say. So SA is a 4 and SB is a 1 and their ratio will be 4 upon 1. This is our final answer. That is how you will solve that kind of a question. Don't make mistake. Not at all. Now next question. Next question. Next question is find the ratio of stage in both wires A and B. A and B. A and B. And figure is like this. This is attached with wire. There is a mass whose mass is 10 kg. One more mass whose mass is 5 kg. 5 kg. It's not realistic. 5 kg. This is a mass B and mass A. R is how much? 2 centimeter. R is the radius of this wire. Okay. And over here, this is R, which is 1 centimeter. This is A. It is asking find the ratio of stress. Again, the stress of this two tension. This two wires, wire A and wire B. Means this will be our ratio. Then we will use formula for stress of stress, not for stress. Question is asking this thing. Yes. Will we care about mass? No, I think no. It's not a requirement. No? This is not requirement. Requirement things are radius of the wire and force. Yeah, force is compulsory. This mass came for the force. So over here, this it will have mg, which is 15 Newton. 50 Newton. 50 Newton plus 100 Newton. Plus 100 Newton. Which will be how much? 150 Newton. And it will have 100 Newton. 100 Newton. But I think it should be 150 or downward. We have a R and force. It is asking what? SA upon SB. Then just substitute value of FA. So over here, try to understand. This will be 150. This will be 150 Newton, and it will be 50 Newton. FA and FB. Okay. So you can say F SA upon SB is equal to F A upon A multiple A upon FB. So look, brother. F is how much? 100 Newton. And A is how much? 1. So pi only multiple. Here area is how much? 2. So it will be pi 2 raised to power 2. And force is 15. This much force, this much force, this 15 Newton force is pulling this mass downward, and this 10 kg mass is being pulled by this 115 Newton force downward. This is what is happening in this figure. Main thing is what is the ratio of stress for these both wires. 50 to the 100, 50 to the 100. 5 will cut to the 2 to the 4, 4 to the 8, 4 to the 8, 8 upon 8. 8 is 4 SA and 1 is 4 SB. So this is our ratio of both wires, 8 upon 1. This is our final answer. Main thing in this equation was how will you find force? How will you find force? Remember, this is not 100 but 50. So this will be 3. 3 4s are 12. 3 4s are 12. Now let's take next question. Next question, which is based on shear stress concept. Shear stress concept. Figure is something like this. This is the object which is attached with this wall horizontally and vertically. Okay, I know it's not a perfect diagram of object, but just understand this is object which is attached with the surface of the earth and with the wall. Now it is saying that force which is being applied on this object is like this, with the 200 Newton, and it is making an angle with the horizontal which is a 30 degree. Okay, 30 degree. This length is 5 meter. This length is 5 meter, and this length is 4 meter, and its height is 2 meter. It means we have a volume type of object, whose dimensions are 5 meter, 4 meter, 2 meter. 2 meter is the height. 2 meter is the height. Force is 200 Newton, which is being applied on this object. It's not perpendicularly, it's not vertically or horizontally, but it is making an angle of 30 degree. This is enough to calculate shear stress. Okay, shear stress. Question is asking, find out the longitudinal stress and tangential stress. Longitudinal stress and I think these are two types of tangential stress on the fixed blocks shown in the figure. Main question is to find a longitudinal stress and a tangential stress. Tangential means the shear stress, and longitudinal means normal to the surface of the object, perpendicular means this component we will take. You can say 200 Newton sine theta we will take for the longitudinal. Are you understanding? So for the longitudinal you would say for longitudinal stress, which is a perpendicular force and it is acting to the normal surface of the body. F upon A. F upon A. This component we are taking, okay? So 200 sine theta is how much? 30 degree. Upon area is how much? For this, I think area should be 5 meter, yeah? So this area, it is asking area. Area of this surface, not the area of the volume. So this is 5 meter and this 4 meter. 2 meter will be for volume, not for the surface. So 5 meter multiple 4 meter is our area. In the previous question we were taking pi r square. In the previous question we were taking what? A circle, but in this question we don't have circle, okay? We don't have circle. We have four line segments which is closed. Okay, so length of this surface would be 5 multiple 4. 5 multiple 4. When longitudinal word is coming, just understand that there is a force which is being applied perpendicular to the normal surface. That's it. This is enough for longitudinal stress. So 200 will be as it sine 30, which is 1 upon, I think, yeah, 1 upon 2. Sine 30 is 1 upon 2. 1 upon 2. 5 multiple 4. 200 was a 200. 5 was a. So this is nothing but 100 multiple 1 upon 20. Yeah, this is correct. So 25 is a 100. So 5 is the nothing but this is a longitudinal stress. But remember, it has a unit. It is not a unitless or dimensionless. Strain is a dimensionless. So unit for this would be, I think, Newton meter per square. Newton meter per square. This is how you will find answer. It was about longitudinal, but what about tangential stress? You know, tangential stress is nothing but like this. Like this force is applied. So tangential stress. Tangential stress is nothing but this is equal to F upon A. F upon A. Take this force which is horizontally. So horizontally would be 200 cos 30 upon area is how much? We are taking this area. 2 multiple 4. 2 multiple 4. Yeah, this and this. But hold on. We are applying force on this point. So this 5 and this 2. 5 multiple 2 will be 10. This is the area of the surface. So area is the same. 5 multiple 4. 200 will be as it. Cos 30 is nothing but root 3 upon 2. 200. 20. 100 upon 1 multiple 120. But remember, root 3 is a still percent. 5. 5 into root 3. This is our answer. This is our answer. Tangential stress. Tangential stress. Now next question. Next question is 40 Newton force. Find out the amount of force required to break the another wire of same magnitude, same material, but 2 times of radius of radius. First of all, let's try to get clarity from the question. What is it saying? It is saying 40 Newton force. How much? 40 Newton force. Is it a restoring force or external force? Let's find out. 40 Newton force is required to break a wire. This is not a, it's a breaking force, okay? Breaking force, not a restoring or external force. Or you can say this is a external force. It's required to break a wire, okay? You can say DF is 40 Newton. Found out the amount of force, okay, required to break the another wire of the same material. Material is same, but 2 times of radius. Means radius has increased 2 times. For example, radius of the first wire was 2 centimeter, then radius of the second wire becomes how much? 4 to z 2 times. How much? 2 times. So you can say for wires of same material, since we have material which is same, breaking stress will be same. Remember, BA will be equal to BC. Reason is material is the same. Material is the same. Breaking of A wire will be equal to breaking of B wire. Reason is material is the same. Material is the same. Clear? That's why you can write like this: B breaking stress 1 is equal to breaking stress of second body will be equal. Since we have what? Can you find area? How can you find area? Question is not provided. It is saying we you have what same material 2 times of radius. We have wire, okay, wire. So wire has a circle. Wire has a circle. So area of the circle would be what? Pi r square. Pi r square. So you can say f upon pi r square is equal to f upon pi r square. This is 1 and 2. 1 and 2. Twist is, main point is over here. It is saying another wire of the same material was the radius has increased 2 times. So here you will multiply this by 2, multiply this by 2, because question is saying we are not applying this to unnecessary from our side. So F is how much? This 40 Newton is for both. Pi r square is equal to F2. Try to see. We are shifting this to pi r square with F1. F1 is 40. 40 multiple to pi r square. Okay. Okay. Again pi r square. Pi r square is equal to F2. F2. This is same thing is cutting to each other, and for two side F2 is how much? 80 Newton. If radius has increased, so of course force will increase. Both are directly proportional. Okay, both are directly proportional. 40 to the 80. One thing that I did mistake, which is try to understand. Area is not a double times. Radius is a double times. Okay, area is not a double times. So pi will be as a 2r square. Radius is a double time, not a area. Now let's simplify this. F1 is a 40. 40 multiple 2 to the 4. 4 pi r square upon pi r square is equal to F2. This will cut. Both the same thing is cutting to each other. So finally, magnitude of F2 is 4 4 is 16, 160 Newton. This is our final answer. Remember, 160 Newton is for another body. 160 Newton is for another body. You can see when we increased radius of a second wire double times, then here for force has increased how much? 4 times. 4 times. 4 4 is 16. 4 times. If you increase radius double times, then force will increase 4 times. This is what will happen. This is what will happen. Now let's take next question. Next question. In a note, write down note. Note is, if the stress is normal to the surface, we saw when we were solving longitudinal stress type equation, then we saw normal surface which force was perpendicular to the normal surface. So it is saying if the stress is normal to the surface, then it will be known as normal stress. Okay, normal stress, simple. If the stress is normal to the surface, then it will be known as normal stress. Second point for note, the stress is always normal to the surface in case of a change in length of a wire or volume of body. Normal will be same. Normal will be same. When the external force compress the body, the nature of atomic force will be repulsive. Yeah, atomic force which are present inside the body, they will repel to each other so that they can regain its configuration. This is what happens when we compress anybody. Okay, when you stretch anybody, then what happens with the atomic or moleculars inside the body? You see that they are attracting to each other. Molecules will be attracting to each other when object is pulled, not pushed. Okay, this is what happens with the moleculars or atoms. Fourth, when the external force expands the body, means body is expanding. Yeah, body is expanding. So what will happen? Nature of atomic force will be attractive. Atoms will attract to each other. This is what will happen when body will be expanded. Body will be expanded. Now let's say difference between pressure and stress. Pressure and stress. Pressure and stress. Do you think that both are same? It seems, but reality is something else. Pressure and stress. We have seen what is the stress, but we didn't see what is the pressure. Let's see. Pressure is always normal to the area. Means force will be perpendicular to the surface of the body. This is what is a pressure. So pressure is always normal to the area, and it is always compressive in nature. Yeah, we are applying downward force means we are compressing the body. We are compressing the body. This is what you can say. It happens. It is the nature of a pressure. And remember, this pressure is a scalar. It's not a vector. As we know, energy is a scalar, not vector. Same, pressure is a scalar. Okay. Now, what about stress? Stress can be normal or tangential, but pressure cannot be tangential. Pressure will be always perpendicular to the normal of the surface of the body. Okay. It may be compressive or tangential in nature. Yeah, we saw that stress was also tangential, it was also compressive, it was also tensile. Tensile. But when it comes to pressure, this has what? Limits. But stress does not have limits. Uh, let's take one more question. After this question, we will move towards the topic. So one question which I have is nothing but a copper wire which is 4.0 meter. Don't take this as a 40 meter. It is a 4.0 meter. I hope you will not make mistake over here. So 4.0 m. This is long and cross sectional area 1.2 centimeter square is stretched by a force of 4.8 multiple 10 raised to power 3 in stress will be how much? This is what question is asking. First of all, let's get clarity. We have a copper wire. So a copper wire which is 4 meter long. Length is how much? 4 meter. And cross sectional area of its is how much? 1.2 centimeter square. Means area is given 1.2 centimeter square. Is a stage. This area, this copper is a stage whose length is 4 meter and area is 1.2 centimeter. When it is being staged by force, whose force is this much, 4.8 multiplied 10 raised to power 3 in stage. In that case, if a force is being applied this much on a copper whose length is 4 meter and area is 1.2 centimeter, then stress will be what? Stress will be what? Can you say stress is equal to F upon A? F is how much? 4.8 multiplied 10 raised to power 3. I know this can be long, this can be bigger number or a small number. I don't know, but I think it should be bigger number, because negative sign is not present anywhere in this part. So 4.8 multiplied 10 raised to power 3. This is a Newton or force which is being applied on the object. So area is given, which is 1.2 centimeter square. This is a Newton. Now our work is to simplify this. What do you think? This will become 48, 10 raised to power 3, 12 centimeter square. So 12 3 za, 12 4 za. I think it should be 48. 4. So final answer is 4 multiplied 10 raised to power 3. This is our stress, which is a Newton meter per meter square. Okay. But this is Newton should be in meter square, not in centimeter square. That's why our duty is to convert this area into meter. For this, we will apply just 10 raised to power minus 4. Just 10 raised to power minus 4. 10 raised to power minus 4. This will convert this 1.2 centimeter into meter, which is compulsory for this stress, because stress has this unit, Newton per meter square. So this will become how much? Plus 3 plus 7. Final answer would be 4 multiplied 10 raised to power 7. In this question, main focus was on how will you convert a centimeter into meter, which is very basic. But most of people do mistake over here. So just apply, if area is given in centimeter, then just apply this 10 raised to power 4 in numerator. If you are going to put this in denominator, then you will have to apply minus 4. Okay, minus 4. 10 multiple 4. This is done. Now let's talk about strain. Understanding strain is compulsory, or you can say is mandatory. This strain will not be ignored at all. Once you understand the stress, the types of stress, once you solve numericals based on it, then it becomes so easy to understand strain and types of stress. Remember, I am saying strain, not stress. Okay. Done. What is the strain? What do you think? Remember, when strain word is coming, then two things you will have to keep in your mind, which is, first will be ratio. ratio. Okay, ratio of force, I think not force first ratio, and second is change. Second is change. Here your focus should not be on force but on change. But on change, because strain will provide change, and even uh, types of strain will also provide change. That's why I'm telling you, think about change when you are talking about strain. So definition for this is, it is nothing but when we are applying uh, deforming force, when we are applying deforming force, then object is going to apply restoring force. In that case, when you applied a deforming force, then how much length has decreased or length has increased? How much length from the original length? That is what is our strength. Length, original length upon original length. So change in the dimension of the body. This is nothing but change in the dimension of the body. Dimension of the body per upon original dimension of the body. Original dimension of the body. Delta L will come firstly, then upon L. Okay. So finally you can convert this into del L upon N, where del L is nothing but it is change in length and L is the original length. Okay. When it comes to SI unit for strain, remember it does not have any kind of units. That's why it is known as dimensionless or unitless. Okay. So remember, this is a unitless, not characterless. Unitless and dimensionless. 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 Unitless and dimensionless. Okay. Now let's talk about, there are three uh, types of strain. This is enough definition for strain. It only provides change in length upon L. It does not have a unit and dimension. So types of strain. Types of strain. Same word will come. Same word means when we were talking about stress, types of stress, then we saw main points which were tangential. First, which was longitudinal, and longitudinal has two types of longitudinal stress, which was compressive and tensile. Then second type of stress was tangential, 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 shear, tangential or shear stress. Then third was volumetric, volumetric. Same word we will say over here. Just replace stress by strain and use this definition when you are replacing stress by strain. For example, types of stress. First type will come what? Longitudinal. I think I'm longitudinal. Longitudinal strain. Here, when we applied a force perpendicularly normal to the surface of the body, in that case, this change in length, of course, I think, yeah, change in length and upon L, will be how much? This will be equal to longitudinal strain. So this is dl upon L. It seems like this is equal to strain, but it may be equal to the strain, but not completely. Now let's visualize this. Initially, this was rod was like this, but finally, object came over here. Object came over here due to external force. Remember, this came due to external force. So how much length this dl has increased? This was L and this dl. This is what we have to calculate, but it will be this will be upon L. Okay, this thing we have to calculate. Okay. Okay. Longitudinal strain is possible only in solids. Remember. This is nothing but mechanical properties of solids. We are not talking about mechanical properties of fluids. Okay. So next, this is enough for longitudinal stress. Next, we have volume strain, and it provides dV, change in volume upon V. Change in volume upon V. Let's visualize. When you apply force on this object which has a volume from each sides, first of all, you decrease in volume will be seen. Now it is same. Initially was this much volume, but when force was applied, this became like that. A small. Of course, a small body we will get. But when you remove, reforming force is removed, then what will happen? It will come to the initial point. So final and initial, this is what we have to calculate upon what? Original volume. So change in volume upon volume, we provide volume strain. Clear? Volume strain. So this delta, which is also written as a D, which means a small change in volume, a small change in length. Clear? There is nothing but volume. Now let's take shear strain. Shear strain. Shear strain. Figure 4 shear is nothing but this was initially present on the surface of the earth. When tangential force was applied, then top surface of the body became like this, but bottom surface is the same. It didn't change its position, but position of the top surface has changed, and that is what we have to calculate. So you know this provides a theta and this also provides theta, which both are equal. Let's suppose this is a B, C, T. This was initial, but E, F, it became A, E, F, D. Okay. And this is a D, L, and L. Formula will be same, del upon L. When it comes to theta, we know that we are going to find a small theta, and you know, if theta is a very small, means it tends to zero, but it does not become zero. That is what is known as phi. You can say phi, but it will not become zero. This will not become zero. So your strain, shear strain will be equal to L upon L, or you can say dL upon L, and this is equal to theta phi, which is equal to theta, and theta is equal to not 0 but tends to 0, but tends to 0, but tends to 0. Now let's talk about relation between angle of twist and angle of shear. Angle of shear. Figure for this will be something else. This was figure of shear strain. It is done. Now we are going to talk about relation between angle of a twist. Twist means curl, uh, and this angle of shear. We are talking about this angle of shear. You can see it rotated with this much angle. It has rotated. So this is what is known as angle of shear. Angle of shear. Let me erase this figure so that we can understand about this. Our focus should be on angle of a twist and angle of what? Angle of a shear. So figure for this is what this is. We have let's suppose a roof, and there is a hollow, or you can say sphere, which is attached with this roof, with this roof. Okay. Okay. But remember, this part is fixed. This part of this, or you can say top part of this a sphere is attached with this roof. So you can say this is a fixed. Okay, this is fixed. Of course, it is going to provide a radius. So this is nothing but this is our radius. This is a radius. And length of this body, this is our length of the body. Length of the body. Length is going to be same for the whole time. It is saying, this is saying that when it was rotated again with an angle, means it has a twisted. Okay, it has twisted. But with how much angle it has twisted, this is what we have to calculate. So let's suppose this much angle it has a twisted, this much angle, which is a very small. This angle is very small, but it tends to 0, but it does not become 0. It does not become 0. Phi or theta. Phi or theta. That is what we have to calculate. But in that case, we are getting radius. We are getting a radius because this is a sphere or hologram. In the previous, when we were talking about shear strain, we had a quadrilateral object, four sides of object, but in that case we have a circular object. Circular object. That's why you will take a radius. Radius is compulsory because with the radius it is rotating. With the radius. With radius. So formula this will be how much? Phi will be equal to r theta upon a. R theta upon a. This a. So r is radius. R multiple theta upon a. This is formula for relation between angle of twist and angle of shear. Now let's explore it. When a cylinder of length L, this length, and it is a cylinder, and radius r is fixed at one end, and tangential force is applied. Tangential like this, tangential force like this. This is a tangential. When tangential force is applied at the other end, this is other end and this is one end, then this cylinder gets twisted. Again it will rotate itself. Figure shows the angle of shear, angle of this shear, and angle of a twist AOA. This AOA dash we are getting theta. This theta is equal to change upon L, but we will replace this change into change A by r theta, and this is what it rotated. This r theta has been rotated by this tangential force. By this tangential force, what was rotated? This r theta was rotated, whose length was this much. Okay, so arc is what? A dash A. This A dash A is our arc. So arc, to get arc, formula would be r theta. To get arc, formula would be r theta. But to get theta, formula will become L upon r. So r theta is equal to L phi, and here L phi will be equal to r theta upon L. This formula came like this. We know arc is equal to r multiple theta. This theta and multiple radius will provide arc, and this is equal to change in length. Change in length. So change in length, you know, change in length is equal to L phi, and this came from here. Change in length is equal to L multiple phi. Okay. And then just put over here. You will get phi is equal to r theta upon L, and this will be used if circular object is coming, like a circle or hologram, a sphere, cylinder. Now let's see a question based on this concept, which concept is relation between angle of a twist and angle of a shear. a cylindrical wire having 1 centimeter and the length 10 centimeter is twisted by an angle pi by 60 radian. Then find the shear strain. Shear strain produced in the wire. After solving this question, we will move on Hooke's law. It is saying there is a cylindrical wire. Okay, we have wire having 1 centimeter and a length. So I think 1 centimeter is a radius. It should be radius. So 1 centimeter. If 1 centimeter is a radius, then we can write r is equal to 1 centimeter, and length is a 10 centimeter. Length of the cylindrical wire is a 10 centimeter. 10 centimeter. 10 centimeter. And this cylindrical wire is twisted by an angle. And angle is how much? Angle is pi upon 60 degree. These are things that are given by the question, and we can write it in our solving area. Okay, in our solving area. So r is 1 centimeter of the cylindrical wire, and L is a 10 centimeter of the cylindrical wire. And this wire is rotated with the pi upon 60, 180 upon 60. I think the angle is coming 30 degree. 30 degree. It is asking find the shear strain produced in the wire. Just shear strain. Concept was the relation between angle of twist and the angle of shear. But question is asking just shear strain. I think it should be equal to shear means tangential strain. So shear strain is equal to tangential strain, which is equal to theta, and this is equal to change in length upon L. Twist is we have cylindrical wire, not a squared wire. Okay, we have cylindrical wire, and wire is not rectangle. This is what is a twist. That's why it will become compulsory to use that formula which we were talking about before this question, which was phi is equal to theta upon r. It provides, I think, it provides arc upon L. Length of the cylindrical wire. It is not looking difficult. Yeah. Phi is what? Rotating part, twisting part of the cylindrical wire. You can use this formula. This is equal to phi, which is equal to theta r L. Remember, theta r is the arc. Multiplication of theta and r provides arc, and length is the length of a cylindrical wire. All values of theta r L are given. Then just substitute pi upon 60 multiple r is how much? 1 centimeter. Okay. Upon L. L is how much? 10 centimeter. 10 6 60. Pi upon 60. 100. So answer is 30. 30 is the answer. Remember, 30 is a degree. 30 is a degree. That is a degree. If you want to convert this into radian, 185 multiplied 30. Just understand this is our degree. But it is not a small. To get a small, you will have to simplify further. Right now I am leaving now from this part.